Welcome to ClickMyProject.com. Deep gross output knowledge transfer using stacked structure least square support vector machines. Next we discuss about abstract. Deep gross output knowledge transfer approach based on least square support vector machines. Its aims is to improve the generalizability of least square support vector machines while avoiding the complicated parameters turning process that occurs in many kernel machines. The proposed approach has two significant characteristics. DCOT-LS-SVMs is inspired by the stacked hierarchical architecture that combines several layer by layer LS-SVMs modules. The module that forms the higher layer has additional input features that consider the predictions from all the previous modules. Cross output knowledge transfer is used to leverage knowledge from the predictions of the previous modules to improve the learning process in the current module. DCOT-LS-SVMs is able to autonomously and quickly decide the extent of the cross output knowledge transfer between adjacent modules through a fast leave one out cross validation strategy. In addition, we present an imbalanced version of DCOT-LS-SVMs is called IDCOT-LS-SVMs is given that imbalanced datasets are common in real-world scenarios. The effectiveness of the proposed approaches is demonstrated through a comparison with 5 comparative methods on UCI datasets and with a case study of the diagnostics. Discuss about flow diagram. First, start, select dataset, clean dataset, split, train and test dataset, classification and prediction. Let's start the program and select dataset. Data selection is the process of determining the appropriate data type and source as well as suitable instruments to collect data. Data selection provides the actual practice of the data collections, and it is the process where data relevant to the analysis is decided and retrieved from the data collection. Data loading refers to the load component. After data is retrieved and combined from the multiple users, clean the formatted and the loaded into the storage system such as cloud data warehouses. Next we discuss about clean dataset. The data can have many irrelevant missing parts. To handle this part, data cleaning is done. It involves handling of missing data, noisy data, etc. Next, splitting a dataset into the train and test. Data splitting is act of partition available data into two portions, usually for cross-validating purpose. One portion of the data is used to develop a predictive model and the other evaluate the model performance. Separating data into the training and testing sets is important part of the evaluating data mining models. Next, classification. Planning is the method of data analysis that automates analytical model building. It is a branch of artificial intelligence based on the idea that systems can learn from the data, identify patterns and make daily decisions with minimal human intervention. It's a use algorithms of two algorithms. Next we discuss about prediction. Predictive analytics algorithms try to achieve the lowest error possible by either using boosting or bagging. Proposed approach is evaluated using some measures. Running of the project. Deep cross output. This is our project name. Home.java. This is our first page. Right click and hit run file. Deep cross output knowledge transfer using stacked structure least square support vector machines. This is our first page. Click next. This is user login page. If you new user, then click sign up. Enter your username, password, confirm password. email ID, enter the phone number and click registration. Successfully updated. Then click OK. Username and password. If you show password, then click show password button. If you forgot the button, then username, enter your username and user email ID. Click forgot button, enter your new password, then enter the new password. Show password, then click show password button. If you confirm password, show, then show password. Updated password record is updated. Okay, then re-enter the username and password. Click sign in. If you then, this is load file page. This page is loaded to the datasets. Then click the browse button, select the directory. I-state classification is our dataset, and then click the load button, and this field is fully loaded the dataset, and then click save button, then save to the database. Data stored successfully, then click OK, and then click next button. Next, view dataset page, and then click view button. Then this table is shown the fully formatted dataset, and then click next button. Then pre-process of dataset. Pre-process is handling the missing irrelevant data. Pre-process successfully, and then click OK button, and then click the next button. Next, data splitting page. This page is split to the train data and test data. This field is shown as train data, this field is test data, and then click the split dataset button. Train data and loaded the test data. Data splitted successfully. Then click OK. Move to the next. Next, we discuss about file conversion page, because we are using VCAT tool. So VCAT tool is access to the ARFF file. So CSV to ARFF conversion. Convert the file. Click the convert button. Then convert the CSV file into ARFF file. File conversion successfully. Okay, next button. Then using algorithms are decision tree algorithm and SVM algorithms. First, click the decision tree algorithm page, get DT result. Then true positive, true negative, false positive, false negative. Accuracy is the ability of classifier. Precision, then ability of classifier or predictor. Recall and phone score, and then click back button, and then SVM algorithms. Click the SVM protect the results. The true positive, true negative, false positive, false negative is accuracy. Precision, recall and F1 score, and click the next button, and this time is click the graph for existing and proposed system, and then click then SVM predict the accuracy and decision tree predict the accuracy. SVM is the existing system, decision tree is the proposed system.